In this, we're going to discuss the second type of structural isomers, which are called positional isomerism, and they are isomers which are formed because of different position of the functional group, which means that the position of the groups of atoms attached on the main chain, they would be different. So, as an example, I would clarify that point using an example. So, as an example, if I have chlorine attached to this carbon atom at the end, and all the other atoms attached to the chain are hydrogen, so let's complete all the bonds. Carbon is going to make 4 bonds in 4 single bonds. So this is chloropropane, and you can see there's a chlorine attached at this point. So let's highlight that, let's circle that chlorine. So there's a chlorine attached at this point, and it's at position number 1. So an isomer of this very molecule could be that you're again going to have everything remains the same except for the position of the chlorine atom, and let's change that position to the second carbon atom, and all the other atoms attached to carbon are hydrogen. So the rest of the molecule remains the same. I've only changed the position of this chlorine atom. So the name of this molecule over here was 1-chloropropane, whereas the name of the isomer of this molecule is going to be 2-chloropropane, because now chlorine is attached to the second carbon atom on the main chain. Similarly, we can do another example to show positional isomers. I'm going to draw butanol, which has an OH group, and it's butanol. So the OH group is at the very end. It's attached to the first carbon atom, and the rest of all the bonds are hydrogen attached to the main chain. Now again, if I want to draw a positional isomer, so OH is attached at the end, what I can do is I can shift the position of OH group from the first carbon atom, which is at the end, the closest to the OH group. So this is the carbon number 1, and I can shift it to carbon number 2. So let's draw the isomer, the positional isomer of this molecule. So again, I'm going to have 4 carbon atom, and the OH position shifts to the second carbon atom, and all the other bonds are with hydrogen. So let's complete those bonds. So you can see for yourself that the OH group position has been changed. It was at carbon number 1 first, now it's at carbon number 2. So this is another example of positional isomer, and let's name the two. So this is butanol. This is the first isomer, and this is the second isomer. This is butanol. Let's do another example of positional isomers, and I've drawn a molecule of but-1-ene where the double bond carbon double bond carbon is at carbon number 1. So let's write down the name of this molecule. It's but-1-ene, and I'm going to try and draw a positional isomer of this very molecule. So I'm going to change the position of this carbon double bond carbon. I'm going to change the position of this functional group. So again, I'm going to draw 4 carbon atoms. Everything remains exactly the same. I'm going to draw 4 carbon atoms, but this time the double bond, I'm putting the double bond in the middle. And let's complete all the bonds. This carbon is going to have 3 hydrogens. It's going to have 1. This is also going to have 1. This is going to have a total of 3 hydrogens. So what I've done is I've changed the position of the double bond. Now it's at carbon number 2. You can count from either side. It's going to be at carbon number 2. So the position of the double bond has been changed. So it's a positional isomer, and the name of this molecule is going to be but-2-ene, because the double bond is at carbon number 2. So these two are positional isomers of each other.